Blockheads, episode 16 of the New Blocks here. Today we're talking about scaling. Hopefully you've had enough time to recover from the DeFi episode. We're going to try to keep this one a little bit shorter, a little more direct, because we know you had a lot to digest this week, and hopefully you had a little bit of time to dive in and get your toes wet, put a couple bucks onto the blockchain, maybe do a little liquidity mining, a little bit of staking. Maybe you bought a couple of sushi tokens. Who knows? Kevin, what sort of non-financial advice do we have to talk about today? Because none of it's financial advice. It's all educational, but I'm glad to be back with you again because I always learn something. Every time we sit down for one of these, I think I've read the notes. I think I know what you're going to talk about, and you always surprise me with something. You're full of little factoids, man.
I appreciate it. Yeah. Well, if any of our listeners did get a chance to start poking around through DeFi last week, they may have noticed that the cost to really interact with it, to interact with Ethereum, start playing around with liquidity mining, buying NFTs, the costs start to add up pretty quickly. When you are submitting transactions to Ethereum, you pay gas in Ether, and regardless of what the price of Ether is doing at the moment, you're still chipping away at your supply when you're interacting with Ethereum. So today we're going to be talking about all the ways that the Ethereum community and the developers and the different teams that are working on trying to make those costs cheaper and eventually sort of approach zero longer term.
Yeah, totally. Like we've talked about this world, this world computer of Ethereum and how it's not at its base level, not really designed to be efficient. It's designed to be secure, right? That's the trade-off there. And if you think about one computer that's being shared by the world, it actually works pretty damn well, given how difficult of a target that is to hit. If you were to have pitched me that idea when we were in college, before blockchain was really popping off, right? So now the next question is, we've set this base layer, we've established some groundwork. How do we build on top of this thing? What's the next level to the pyramid? We're going to talk about some of those scaling solutions today. That the layer 2, we've heard that talked about a lot on social media right now, and excited to break that down a little further. So where does it all start, man? What's our first step when it comes to scaling? And I guess we're not only going to talk about Ethereum today, we're also going to talk a little bit about Bitcoin and some potential scaling solutions for that network as well.
Yeah, and it's because scaling is a pretty general concept in computer science. And, as a software engineer, it's something that I sort of think of my role and my job is to always continue to increase the bandwidth for whatever it is I'm doing. If you think about early internet, right, you've plugged into AOL, you heard all the crazy garbage sounds coming out of your computer, and you get to a web page and you're seeing the image download, and it's line by line filling in the pixels.
Oh my gosh, you're right.
Yeah, and early days internet, your bandwidth was in the kilobytes, and every image that your computer was downloading was a really big deal. So the concept of increasing scale is really just bringing this to masses, and trying to increase the total supply of a thing. So when you're talking about improving the scaling of the internet, you are making it easier, faster to send larger and larger files around. So we start with, you can have images. At first you start with just text, right? It's the condensed information that we can send around to each other on the internet. We start with just emails, and then you eventually get pictures, and then eventually you get videos, and then eventually you get higher resolution videos, you get virtual reality, and suddenly, the bandwidth is just so, it feels like the challenges of yesterday are just so far gone, and we're living in this world where internet bandwidth is just so cheap.
Yeah, and it's also continuing to trend that way, right? We're not averaging lower quality or like video size overall. I guess efficiency is still improving, so we're getting better quality per size, but the inequality is increasing so quickly. I mean, 4K is kind of established now. I've heard people talk about experimentation with 8K. I don't know what you would ever need that for, or why you'd want to fill up a hard drive with a movie. But somebody somewhere is like, bro, I got my 8K webcam right here. It sits on my shoulder. Like when I'm on the mountains, you can see everything. It's definitely there. And with blockchain, it's no different, dude. So is it just as simple as expanding block size? I mean, that's where it started, right? There's been so much history in the blockchain space fighting over block size. That's a key part of Bitcoin's history right there.
Yeah, and so there was back in the Bitcoin era prior to Ethereum, there was the block size wars, and it was these online arguments about the idea of potentially increasing the Bitcoin block size. And you think about a blockchain, every time that you're adding a new block to the end of it, you're adding on more data, and there's an upper limit to the amount of data that any particular blockchain will allow for. So that way, you don't have people uploading their new 8K videos into the next block. And so the reason why you would want to keep that block size limit relatively low is that in order to run a node on any given blockchain, you have to run a little computer with a hard drive attached to it. And if your blockchain is, terabytes in size, the barrier to entry to running a node starts to increase. So you think about the difference between something like Bitcoin, which is like, I haven't pulled up the numbers lately, but, in the gigs to be able to run a node. Whereas an Ethereum node, because there's much more rich data that exists on the Ethereum network, it's a couple terabytes now. And so the block size debate in the pre-Bitcoin days was Bitcoin began to start to groan a bit. Transaction fees were starting to go up, and people were wondering like, well, what happens if we just increase the block size? And so eventually this argument was settled in a hard fork where some set of the miners decided to go download this new version of the Bitcoin code that would allow for larger block sizes, and thus created the Bitcoin Cash fork. And what we ended up seeing was the version of Bitcoin that didn't make that change was the version that was continued to be adopted by the masses. So that's what we still call Bitcoin today. Yeah. And the reason being that the Bitcoin community and most blockchain enthusiasts are kind of the mindset that the more you have to increase the block size of a blockchain, the less decentralized it becomes longer term, just because the cost to run a node just starts to skyrocket as you increase block size.
Yeah, and that whole situation, I don't know. I remember listening to Vitalik talk about this on a couple of podcasts, and I think I hope I've got this right because it starts to get a little political here, Kevin. Buckle your seatbelt. But the way the big block side panned out, it felt like it got hijacked a little bit because I think there was a reasonable case of, yeah, sure, you can't make it too big, but do we have it necessarily set at the right number now? Doubling it does give us a little more breathing room and might still be within this reasonable threshold, right? I think that's the conversation a lot of people wanted to explore, and then it got taken over by the Bitcoin Cash folks, the Roger Ver crowd, and then a lot of the more reasonable voices didn't want to side with them, but then were left really without a side. It was the Bitcoin Cash became the big blockers, and then the Bitcoin OGs or the purists or whatever you want to call them became the small block guys. And those of us in the middle that were kind of like, I don't like either of these. I don't think either of these are the right solution. Damn it, why can't we just compromise on the middle ground that makes more sense? We were left without a team. So Vitalik was, we're just over here on Ethereum kind of doing our thing in a totally different ballgame. Is that an unfair summary of the way that panned out? Did I get it right?
Yeah, you got it right. And the reason why we ended up with the solution where there was these like very large blocks on one side and a do nothing crowd on the other, the do nothing crowd, whether they realized it or not, tapped into this like human psychology. There's a name for it. I'm drawing a blank on it, which is that it recognized that if you even, increase it by 10%, right? Increase it by 1%. if you set the precedence that you're willing to increase it at all, you are opening up this debate to continue again and
It's like
again
a
and
Pandora's
again.
box thing.
Exactly. So the do nothing crowd sort of recognized that, like, yes, maybe Satoshi Nakamoto didn't come up with the ideal number of the ideal block size on day one, but if we start playing with that attribute, we are going to be having this argument very often. So we need to
value
scale
immutable above all, basically. That's
Yes.
what that comes down to. Okay.
Yes.
All right.
And within the Bitcoin crowd, that resonated enough to see what we see now, which is, this huge lion's share of the nodes in the community consolidating around what we call Bitcoin, and these like smaller fractal branches. Eventually Bitcoin Cash branched off into ABC and Satoshi's Vision, and smaller and smaller communities that are
talking
more
about
and more
shitcoins,
nuanced.
Dude. My God. Oh, Jesus.
Yeah, exactly. So expanding block size is clearly not the way that we move forward, scaling Ethereum and scaling blockchains. So the next, vision of how this might happen long term is this idea of many different blockchains.
Okay.
It's a world where there's not just a single one.
So this is the Litecoin argument, right? This is very near and dear to my heart. The silver to Bitcoin's gold, the easy onboard, the faster, basically like the guaranteed beta test network for Bitcoin, as it turns out. And they have carved out, weirdly enough, a little niche for themselves. I have lost more money on Litecoin than I've made, and they were my on-ramp into crypto, and it's because I've misread it so many times. I was bullish on it when Charlie sold, so that was a mistake, and I was bearish on it during this last market bull run, where I didn't necessarily think Litecoin would follow suit with everything else. So it does seem like there is some merit to this, but at the same time, the deeper I fall into the Ethereum network, the more I feel confirmed, and like I don't really know what Litecoin's future is, and there's a lot of other versions of Bitcoin is to Litecoin as Litecoin is to a bunch of others in tiers below that, like Vertcoin and all these kinds of things, and it does make you wonder what is going to happen to them. Is there a place for silver and bronze and various other earthly metals that don't really matter so much in those sort of analogies?
It's hard to say because, right, on the pros, you have this path forward to scaling where you sort of like fragment the use cases of crypto. So it's easy to talk about when we're doing, Bitcoin versus Litecoin. It gets a little more challenging when you're talking about the Ethereum, the smart contract platform world. But you scale it by fragmenting the use case, where if you want the most robust, most secure currency, you've got Bitcoin. And if you're just moving money around to go pay your friends, you've got stuff that may not be as secure, may not have the same number of miners that are running the network, but you've got way cheaper fees, and you've got sort of the ability to use it more day to day. But it's still like the biggest con here is that you are breaking apart the kind of like most important and most limited resource of blockchains, which is the security, the nodes. You're breaking apart and you're making them compete together. So you're running a node. What are you going to run? You've got this whole like spectrum of different blockchains, right, with different adoption within them, and essentially like your blockchain, if it's a smart contracts platform, you need to convince miners to run your node. You need to convince developers to build apps that integrate with your blockchain. You need those apps to then convince users to go use the blockchain. And so it's this network effect that you're fighting against these like bigger established players, where this like multi-blockchain future, it doesn't seem like the most logical way forward. It is a little clunky, and that's not to say that like there's only ever going to be one or two blockchains. Like there's like you mentioned, Litecoin still surprisingly kicking around. And like, who knows? Maybe there is this sort of like all of the things
It is more practical, right? I have bought and sold multiple L3 Litecoin miners, okay? Because that's been, we don't need to go down this rabbit hole, but we could do a whole episode on Litecoin where I'd be happy to go deep on the really weird tokenomics of it since they started merge mining with Dogecoin. And like, dude, it's actually kind of interesting. That ended up being a really big boon to the Litecoin economy. So there hasn't been a lot of new hardware made. So the same L3s that I bought in like 2019 are still kicking now and more profitable than ever because Bitmain's not making hardware for the Litecoin network because they also predicted it to sort of go by the wayside. And it hasn't, especially like who would have predicted the resurgence of Dogecoin? I mean, come on, man. That's some like once in a lifetime kind of a thing.
It's weird.
Yeah. But every time I've done it, when people are like, well, how do you want to be paid? Bitcoin or Litecoin or whatever else? All things equal, Litecoin's pretty damn easy. It's way faster than Bitcoin. The fees are way lower, and it's accepted in basically all of the same exchanges. Every time I've been able to just get it right on Coinbase, turn it into Bitcoin, turn it into cash, turn it into Ethereum, whatever the hell you want to do. I've never been disappointed with a Litecoin transaction, and I've used Litecoin for like large transactions. The first miner I bought was thousands of dollars. So it is practical, even though it's easy to kind of poo-poo in theory when you're actually out there using it. I mean, have you ever bought something with Bitcoin and then sat there and waited for 6 confirmations before the person gives you the thing out of escrow to confirm it? It's actually a painfully long amount of time.
Here.
Yeah. I mean, I learned that one the hard way. A really old piece of mining equipment I bought, the first one. And you're sitting there with the guy just like, man, only 3 out of 6, huh? It's been an hour and a half. Fuck.
Yeah, and if you're trying to buy anything larger than a keyboard or a cup of coffee, you're gonna want to wait even longer just to really be sure. And 10-minute block time is just painful.
Yeah,
I mean, even on the smart contracts platform side, we still see this sort of like fragmentation of. We had mentioned the term like Ethereum killers in the altcoins episode. We talked about stuff like EOS, Tezos, Solana, Binance Smart Chain, Near, Tron, Cardano, Algorand. These are all. There's so many of it, and there's like a long tail curve. There's like even newer ones like Terra Luna, Avalanche, Thor Chain, and so like there is still clearly people that hold this vision of like, okay, like maybe Ethereum will be the main layer, and maybe there's like room for these others that like could potentially establish a niche in different areas. But I mean, for me, like just given how much time I can spend learning about blockchain, as much as I wish I could expand that to just be infinity, I can't realistically put enough effort into like every single one of these to know like what is actually solving interesting problems, what's establishing a niche, and like what's going to be able to fight the network effects of such an established player like Ethereum. And so far, I really haven't seen anything that's interested me in that way.
Well, and we're also just seeing this pattern of like developers, and within this decentralized ecosystem, there is still a pretty organic amount of centralization among the developers, because developers want to go where other developers are, because then there's more support for that ecosystem. That's going to happen no matter what you do. There's some. It's hard to imagine all of these. I guess what I'm stumbling to say is diminishing returns, Kevin. TLDR there. Each additional Ethereum killer feels like it's harder and harder to see it actually being an Ethereum killer.
Yeah, I mean, as a software engineer myself, like I can tell you, I've put the effort into learning Solidity, and that gives me access to the largest group of users, of other application developers, of real infrastructure that exists, applications I can tie into. Mm-hmm. It's not worth it for me to go take the time now and like go learn the necessary smart contracts platform on Solana or Cardano or any of these other ones, just because it's like I'm okay. I think I'm gonna go ahead and just put my eggs in the Ethereum basket when it comes to what I'm willing to learn as a developer.
Right. Yeah. Absolutely. So, all right, what do we have next in terms of scaling solutions here?
Yeah. So the next vision here, and as I'm talking through all these different I'm calling them visions just because these are like different approaches to scaling, but these don't necessarily have to be mutually exclusive. We can kind of, I'm foreseeing a world where, some elements of these different solutions may survive, some elements may not.
Okay.
But so the next vision of a world where we can scale blockchains is this idea of like a meta protocol. And again, we chatted very briefly in the altcoins episode about a couple, but Cosmos and Polkadot share this vision. And it's essentially a protocol of protocols. If you think about a blockchain similar to the way that you think about like HTTP as this protocol that we use to like send internet requests, we use TCP/IP to know how to like package data across the network. A blockchain is just another protocol in that way. So you have software that can, as long as it can speak this language, then whatever machine, whatever language you're working with, can work with it. So a protocol of protocols would be one where we create abstractions of concepts within the blockchain ecosystem, things like blocks, things like consensus mechanisms, and we create these abstractions to where there is this like more generalized language that you would use to be able to create your blockchain that you want to use for selling your pet rock application, or another blockchain that, maybe one you have over here, it's like optimized very well for a particular programming language. It wants to use like proof of stake. And then this other one, you can just like spin up this other application blockchain that has completely swapped out its consensus mechanism. It has a totally different concept for how it organizes blocks. And so it's essentially this idea of a world where instead of having all of these different blockchains that are competing for security resources, competing for node operators, we could have this meta protocol language that allows for all the expressivity of the like different types of blockchains that want to exist in the world. But as long as they all can speak this meta protocol language, you can actually pool the security resources and have a single node that is capable of running all of these different blockchains.
Okay. I think that makes sense. I'm picturing
it's like, a bit more complicated than the previous visions.
It's like this web where it has all these different interfaces that can talk to all these different blockchains that have all these different protocols, and that web comes into like a central source, and that central source is the connection of all these blockchains that can now kind of talk to each other. It's like a network for the network almost.
And the big win and the big reason why this vision exists is that the fact that your blockchains don't need to compete with each other, and you can just have this single layer that exists. And to a degree, that's what Ethereum is doing by building this platform. Yes, there's only a single blockchain in Ethereum land, but it's this open platform where anyone can build on top of, and you don't need to compete. In a similar sense, you could think of Cosmos and Polkadot as like trying to go for that vision, but just implementing it in a slightly different, slightly more complicated way. And that's kind of where you get into the cons. This is a bit more complicated. It's going to require the same sorts of network effects that Ethereum had to go through in order to like establish a following and find people to build stuff for it.
Totally. Sounds like really cool in theory and very difficult in real life. That's I guess sort of the summary there, but very interesting. I've seen Polkadot and Cosmos talked about a lot, so that's good to have some context there. So what do we have next? I guess now we're starting to get into like payment channels and stuff like that that's designed for merchants and commerce and relatively trusted fast transactions. And by trusted, I mean it's like a storefront that has some sort of, a company or brand behind it that's a little bit centralized. And generally the transactions are coming from customers that are buying products, and kind of like how PayPal, if your account is in good standing, they give you a little more leeway if somebody wants to request a return or a refund or something like that, versus if you have a bunch of dings on your account. What do we got going on in the payment world?
Yeah, so this concept of a payment channel or a broader concept of a state channel is one where you have a network that is separate from the blockchain network. So in the Bitcoin world, you have the Lightning Network, and it is a way to be able to send Bitcoin around quicker, more efficiently, cheaper. And the way that it does this, you think about, I like this example. I've used this before. You hang out, you go to the bar and you want to get a drink. You hand them your card. They have it, they'll hold it back there. And every time that you go up and ask for another drink, they're not swiping the card and like going through the payment processor every time. They are sort of like keeping the tally on this additional, in this case, additional network, but in their own computer. And that doesn't have the same constraints as actually going through the payment processor, actually submitting the transaction to the Bitcoin blockchain. And so it's this version of scaling where you can do pretty basic payments in this like really fast and scalable way where, after you've had a few drinks and you're ready to close it out, you can just go ahead and get your card back, and you're sending one transaction that sort of like bundles a whole series of different transactions within it. And where this concept gets interesting is this like somewhat more complex explanation. But now imagine that you could take all of your own your bar tab with yourself and the barkeeper, and then that barkeeper has, maybe they've established a payment channel with you. Maybe I owe you a beer. And I could, ask the bartender to do some sort of a transaction where like my tab includes one of your beers, and you can create this like this entire network of payment channels where these different nodes are connected to different users that all are trying to send money to each other. And you can have this whole world where you're sending around these fully valid Bitcoin transactions that at no point do you ever have to drop them down to the base layer and actually submit them up until the very end. But if you are always holding on to a signed Bitcoin transaction that you know for a fact that you can always go and redeem it on the base layer, you can actually just hold on to that on the Lightning Network. And so you can think of this as this like really quick and scalable version of Bitcoin that gives you the assurance that at any point you can go take this back to the base layer and redeem it for the underlying Bitcoin.
So it's kind of like almost a batching type concept where you say, hey, I love that bar example. You give them the credit card, and then at the end of the night, they do one transaction of $50 instead of 10 transactions of $5 for all the beers that you bought. This is sort of the same concept where the store says, hey, here's all my transactions for the day. Let's just say, conceptually speaking. And at the end of the day, they double check it and go, okay, yep, that's good, that's accurate. And then all that gets pushed in one big transaction in like one fell swoop. So that way it's way less fees per transaction on average rather than doing them one at a time. Is that the general concept?
Yeah, that's right. And then the only additional layer on top of it is that bar is then connected to all of these other e-commerce, different companies that have the ability to then go settle up between them. So that bar could use this mechanism to go pay their distributors or pay for their like restaurant equipment. And so all of this then connects to each other and just creates this big network where you're sending all this money around, and at no point is anyone really required to go submit that into the blockchain unless they really want to.
Okay. Now, that sounds really awesome, but I love this note that we've got here that just shows the scale difference here because in terms of Bitcoin, one of the things that you can do with it besides just having it sit there is turn it into wrapped Bitcoin, right? We've talked about wrapped Ethereum before. It's just this one-to-one, what did we call it? Is it a pegged coin? It's not exactly a stable coin. It's
Yeah, it's closer. I think I would think of it as like a peg. Where it's like, you pass it through this mechanism where if you want to send a Bitcoin to the Ethereum network, so you can do stuff with it, like on DeFi, you can pass it through, and it will lock up a Bitcoin on the Bitcoin network, and it will mint a a wrapped Bitcoin on Ethereum.
Yeah,
and
so
there's a
it's
bunch of different
like
ones.
one-to-one collateralized, and it's like just
Yep.
and so you can redeem it at any time. So in terms of adoption, though, there's 1,800 Bitcoin worth of value on the Lightning Network, and 254,000 Bitcoin worth of value on the Ethereum network. So, like that's a lot of zeros, man. That's more than 100x. Yeah, that's whew. So
and
yeah.
that's leads to where I, again, similar to the protocol of protocols approach. I like the vision of the Bitcoin Lightning Network and just, of payment channels in general, but there is some complexity with setting that up. And I think that complexity seems to be a big enough barrier to entry that we are just not seeing anywhere near that adoption. So like you said, I think it is like 250x of like Bitcoin on Ethereum and through various projects. There's other ones aside from wrapped Bitcoin. There's like RenBTC, SBTC, bunch of them. But regardless, it seems at this point that Bitcoin is scaling on Ethereum. It is not scaling on the Bitcoin Lightning Network. And as much as I would want it to have its own scaling solution, it doesn't seem to be panning out that way. I'm happy to change my mind, happy to like get excited again when the Lightning Network, if it takes off, but it's not really what we're seeing right now.
Yes, Kevin, he could save others from death, but not himself.
Yeah, I feel that.
All right, well,
let's get to the next one.
Yeah, so Plasma, side chains. This is cool stuff. This is getting into more contemporary times and real, like, faster scaling solutions.
Yeah, so side chain is a concept that often gets confused with the following bucket that we'll talk about, which is layer twos. But a sidechain is another blockchain that exists. You can think of it on the side of an existing blockchain, like Ethereum is a good example, that has a few different popular sidechains. And the way that it works, similar to the way that we just talked through wrapped Bitcoin, having this mechanism to like send it to a different network, you have this additional blockchain that you send some ether over, and it creates wrapped ether on this blockchain that doesn't use the same nodes. So you still need new node providers that are running new software. So you gotta go through the same bootstrapping network effects process, but you get some pretty huge efficiency improvements from this. I think for some examples here, something like 7,000 transactions per second when Polygon was doing their testnet was the last time I checked, versus 14 transactions per second on the Ethereum base layer. So you can essentially have the version of, you take a clone of Ethereum, you make it so that people can use this clone of Ethereum, increase the speed, huge bandwidth improvement, much cheaper. And it's because of this two-way peg concept where you lock up the ETH in the Ethereum side, and then you go mint it on the sidechain side, and then vice versa. You burn it on the sidechain, that will go ahead and unlock it on the base layer.
This is pretty solid, right? This, of all the scaling solutions we've talked about, this by far sounds like the most practical thus far. Correct?
Yeah.
Like we're actually seeing this in practice right now. Like that's kind of what you just described is the basis of the Polygon value proposition.
Yeah. Yeah, and Polygon's not the only one. I mean, XDAI has been around for a bit. It is a sidechain specifically for DAI, the US dollar stablecoin. But even Ronin is a sidechain, so it follows this model of being this like separate network that can really increase bandwidth and capacity. And I know from an Axie perspective, that's a must.
Yeah, no, totally. And with Ronin, like the key thing is having a bridge where you can send stuff back and forth, and that's where again this clone of Ethereum comes into play. And in the case of Ronin, it also it kind of doubles as like what would be MetaMask. So it's a wallet that lets you interface with stuff that also has its own side chain, which is closer to its unique value proposition. So in the Axie case, that scaling solution is, hey, we need to rebuild all of the basic infrastructure specific to our gaming needs, because most of these tools were built for more practical applications, not necessarily gaming. And being able to control that sort of foundation layer from a software perspective is pretty powerful for scaling on our side. So yeah, Ronin, I think right now it feels a little bare bones, but once there's like an Axie Infinity DEX, a decentralized exchange, the Ronin, like browser plugin and the whole sidechain concept will really come into focus.
Yeah. And I think that kind of leads us to, we've got two more here. The last one's pretty quick. Layer 2 is this concept of, you take this concept of a side chain, you move it on top of the other blockchain. The main difference here is that a side chain is its own separate network that has its own security resource, its own set of nodes that you are putting your trust into to run the network. Mm-hmm. A layer 2 solution, a layer 2 network, utilizes the security layer of layer 1 of the Ethereum blockchain, and is able to essentially leverage that so that you aren't required to put trust into this other smaller network of validators, and can sort of utilize all of this work that's going into proof of work and proof of stake on layer 1.
So side chains are like a clone, and because they're a clone, they can easily talk to Ethereum, but you're cloning everything. So you're also like mimicking the security protocol, which means you got to run nodes, you got to find validators, you got to have proof of work or proof of stake or some sort of consensus mechanism to secure your side chain is its own blockchain. Ethereum's a blockchain, you have another blockchain that just works similarly to Ethereum. A layer 2 takes Ethereum and then just builds another layer on top of it, and it uses the Ethereum like security protocols, the logins, so to speak, and all the security mechanisms. It's not reinventing the wheel the same way a sidechain is. So like they feel similar, but they're actually pretty different in like their fundamental mechanisms.
Yeah. So most of the layer 2s that I hear about that are being worked on use this concept called a roll-up. And a roll-up is, simply put, imagine you're rolling up your sleeping bag at the end of your sleepover with your friends, and you're trying to compress that as much as possible. You think of this in a blockchain sense, and you take as many transactions as you can that would otherwise be individual blockchain transactions on layer 1. You roll them all up together, and you compress the data. You submit a single transaction into layer 1 that may have thousands of transactions on layer 2, and now you have this like huge scalability and efficiency increase that has the same fingerprint as just one.
So that sounds kind of like Lightning Network when you put it that way.
In the sense that it is, yes, it is like compressing the need to have many different transactions. Now it's all just down to one. And really, at the end of all things, this is the long-term vision of the Ethereum base layer. Today, when you and I are hanging out on layer 1, we sort of have a luxury that will not always be the case because we can afford it right now. It's not ridiculous. It's like $5 to go submit a transaction, to go send money on layer 1. That won't always be the case. As soon as we start to like have more and more use cases, layer 1 will likely be for layer 2 roll-up transactions. Like that is probably more so what that layer 1 is going to be. Just all these very compressed data transactions that are all kind of like leveraging the security of layer 1.
I mean, that kind of makes sense when you said that the Ethereum blockchain is terabytes earlier. That's sort of humbling, I guess, in terms of how like there's acceleration to the amount of data that people want to put into the blockchain. So that means we have to have acceleration in terms of scaling. Hopefully faster on the scaling side so that we're making a dent in how efficient the network is. So talk to me about these optimistic rollups. I know we talked about this before the show started, but I've already forgotten what the key difference is.
Yeah, so there's two types of rollups that are sort of being thrown around in the layer 2 world. There's both optimistic and ZK rollups. The main differentiator is the math that gets used. It's not worth going into too much detail, but maybe just to talk about how the user experience changes. With an optimistic rollup, it uses this math called a fraud proof. And with a fraud proof, when you are submitting a transaction, when you're taking your layer 2, you've got some money up here and you want to bring it back down to layer 1, you have like a 7-day wait period. It's different depending on the network, but there's the wait period here where a validator can go look at all the transactions and try to detect fraud in that way. So it's called optimistic because it's like, let's assume good intent and then have this process, this like court system that allows us to be able to like catch fraud if it does occur.
Okay.
I think there's a good example of like, you don't go to court to cash a check. You go to court if the check bounces. So you don't need like this really, you don't need every transaction on layer 1. You don't need this like huge like entire network to scrutinize your transaction. Like you really just need it to find these cases of fraud. Whereas ZK rollups, ZK stands for zero knowledge. Zero knowledge is this concept in the math world where you're interacting with stuff without necessarily needing to know the specifics of it. But again, without going to a ton of detail here, the main differentiator is that ZK rollups do not have this same wait period. It uses what's called validity proofs. And for that reason, it's a bit of a better trade-off in terms of like of simplicity and efficiency. But it's a bit more complicated, and therefore the optimistic rollups that we're seeing that are coming out right now are kind of a lot closer, a lot farther along than some of the EVM compatible ZK rollups. So on the optimistic side, we have Arbitrum and Optimism. Both of these are pretty big projects. I think Uniswap just launched on Optimism this week. Both of these are in kind of a beta mode to a degree, but they are pretty dang close. Whereas the ZK rollups, there's another subset within ZK rollups where there's like a primitive version of a ZK rollup where you could do kind of like basic, payment channel type basic sends and exchanges and stuff. But a full EVM compatible Ethereum virtual machine like version of a ZK rollup is pretty far out. I think ZK Sync 2.0 is one example of this. But I don't really have
Still
a timeline on what that looks like.
Yeah. I think those simple analogies that you have here really help tie this together. Like you don't go to court to cash a check. You only go to court if the check bounces. There are some like general assumptions where at face value you want to say, well, if you don't check every one, won't people just abuse it with fraud? But when you think about the general like social consensus mechanism that exists in most other aspects of our lives, especially like in financial sectors, we do assume some trust at certain parts in the system because it's overall more efficient, and dealing with some of the fraud retroactively and creating punishments and disincentives and whatever ends up being a net more efficient system than having a court verify every check, I guess, would be sort of the ZK rollup strategy, right?
Yeah. I think that makes sense. And I mean, I think both of these rollups are kind of seen as the like the longer term approach to where things are going, just given the fact that, or just maybe layer 2 solutions in general are kind of seen as a bit safer than a sidechain for that reason. And therefore, that's why the difference is that the complexity that comes with it is sort of like what's pushing these projects to take longer.
So the very last one here, sharding. This is a really cool concept, and this is the idea where you take the big blockchain and then you break it into pieces, right? So you take one blockchain and break it into like 64 mini blockchains. Then random validators are assigned different parts, aka a single shard of the chain. They verify that, then the network pieces them all together, kind of like BitTorrenting style is almost how you could picture it. And then the whole network at large can paint the picture of the entire blockchain, but no single node is storing the entire thing at any given time. So I think overall, like that is a great scaling solution that could work for Ethereum and other blockchains. Where is there a downside to it? Is there like a catch to sharding? Because I can't really think of
Not really,
one.
other than just complexity. And that's sort of what is. So sharding is part of the Ethereum 2.0 upgrade. It is a phased upgrade for that reason. It's just a very complicated process. And so it's one of these things, though, that like it's going to start with 64 shards, but it's a number that can be semi-easily changed once that has been implemented. So we can kind of treat sharding as like a maybe safer way to like scale layer one than the multi-blockchain vision that we were talking about earlier. A final note before we get into lightning round, I think of scaling as more of a journey than a destination. I think it's easy to think of back to the internet analogy, like we're not going to be just done scaling the internet, right? Like now that we have the ability to like stream 4K, you've got people that want to be able to stream 8K.
Yeah.
And maybe it doesn't make sense to us now, but maybe when we get to that point where it's just so cheap, we can start to do things like stream two 4K images in a bubble to create this like 360-degree camera, and you can have like this entire virtual world where people have like, you start coming up with ideas. Developers like to come up with ideas. They like to use whatever constraints they have and just keep pushing it. And so as soon as there's like new bandwidth in Ethereum, that just opens up new use cases that developers are going to try to fill that gap. And we're going to have to keep coming back to the drawing board and figuring out what's the next layer of scaling, what's the next way that we can start to alleviate some of these transaction fees.
Yeah, no, totally. Again, a perfect analogy. We're never going to be done scaling the internet, and this is just the next version of that. So the needle moves, I guess, as they say. But let's do some lightning round. This has already been another long episode, so I think we've only got a couple here. But Kevin, if we end up with a bunch of different layer 2 solutions, won't we start losing the composability of DeFi, sort of that diminishing return aspect that we talked about earlier? Doesn't that have the same issue as the multi-chain solution at a certain point?
Yeah, in the short term, totally true. We're looking at with new layer 2s, with Optimism rolling out. Uniswap exists on optimistic Ethereum, but it doesn't exist over in Polygon. And so we're starting to see this kind of fragmentation that is occurring. And in a short-term sense, that sort of does come at odds with the composability of DeFi. DeFi is interesting when you have these money Legos that you can just tie into each other. Everything sort of like speaks the same language. It's on the same network. And you can just connect everything. When you start to introduce new layers and these layers don't talk to these layers, that starts to fall apart. What's interesting is that I anticipate we're going to move to a place where we start connecting these layer 2s together. So there's one project I found that was trying to do this called Connext, Connext. And its goal is to be the glue between layer 2s, between these different scaling solutions. So I anticipate it'll be, it's going to get worse before it gets better, but then we'll get to a world where you can kind of just like go submit your Ethereum transaction and it's just going to bounce around through all these different layers and all these different like subnetworks and figure out what the best place is for the thing that you're trying to do.
It's always so meta with you, though. You're basically just describing Yearn for layer 2s after we have a Polkadot for the layer 2 scaling solutions. It's just layers upon layers of scaling. So some of those concepts that didn't work for layer 1 scaling might work to tie the layer 2s together. And then that opens up a whole nother web of efficiency. Damn,
I think
dude.
Payment channels are actually a great example of that, where payment channels, maybe things aren't working out with the Lightning Network, but like that's a cool technology that could be used as a glue between different networks, because all you need to do is just have an efficient way to send value between two places. You don't necessarily need full smart contract compatibility to like exist in that glue area.
All right, one more for you, buddy. We're going to wrap this thing up. what does layer 3 look like? I know now we're getting like super far into the future. A lot of layer 2 isn't even implemented yet, but like, where are we going with all this? What does scaling look like? Are you about to hit me with some theory of unlimited energy, unlimited data, and the future of humanity? Like where are we going?
Yeah, it's hard to say because yeah, as you mentioned, we're still building layer 2. What does the end state of layer 2 look like before we start bumping into the same bandwidth issues that we're hitting on layer 1 and eventually hit on layer 2?
This is like 1995, and I'm asking you what Web 3.0 looks like, and you're like, I don't know, dude. GIFs are like, pretty cool. Like they kind of load, right?
Yeah, exactly. So I think it's a bit too soon to tell like if and what a layer 2 will look like, or what it'll be. Sorry, a layer 3, what it will be for. But I do kind of anticipate the way that we are scaling between layer 1 and layer 2 is this. You think of like a fractal where on layer 1, everything is like, the most expensive. But as soon as you hop to layer 2, it's like orders of magnitude cheaper, orders of magnitude faster, and it kind of like spins off into this like fractal where you can have like all of this extra bandwidth here. So if we do get to this layer 3 world, I could foresee a situation where you have that same sort of efficiency, like order of magnitude increase in bandwidth that could exist off of like you roll up your transactions into layer 1, plop it on layer 2, and then maybe there's this like additional layer where you like roll up those transactions and go into a layer 3. But I'm just speculating at this point.
Yeah.
It's pretty soon. It's pretty early to try to figure out what that looks like.
It's pretty cool though that we have so much theory still to implement to see where this stuff goes. Like that's what makes me so excited and bullish overall. It's not like we've hit a wall and the limitations of current blockchain tech are just like, yeah, I don't know, we're going to need some really creative young guns. Like, no, people have come up with some really cool ideas. We're in the process of building and implementing these ideas. It's just new and challenging and taking a lot of time to build. But as we brought up a number of times, like Ethereum 2.0 is right around the corner. I mean, we had said months ago that by the end of the year is what we were hoping for. And I think that timeline's been moved up even more, right? I mean, we might have an ETH 2.0 episode in like a matter of weeks here. And that represents the pinnacle of scaling in terms of, the second biggest blockchain in the world.
Yeah, I mean, we're going to definitely cover it before that merge happens. I think their timeline is still, sometime before end of the year. There's another really big update that I want to get to and talk about before it happens in August called EIP 1559. So maybe we'll try to jump into that at some point. Yeah. But there's a lot of really cool efficiency improvements that are coming, and that's what I'm here for.
We're going to save the world, and we're going to save the planet along with it, Kevin. It's just taken us a little bit of time to get ahead of the curve there, but it's happening slowly but surely. All right, buddy. Well, that's another one complete. Thank you so much. Appreciate you, Kevin. Appreciate all y'all at home listening and watching. Thank you so much for your support. Appreciate any kind of reviews, likes, comments. We want to hear from you. Any thoughts or questions? If you're confused at all or you have any additional lightning round questions, hit us in the comments. We're paying attention, and we'll try to hit you back with the best answer that we can. But until next time, enjoy the blockchain world, because we'll be back again with more.
See y'all.